So like we saw in the product and quotient rules, this is the product rule.
Yeah.
And as it states, u and v are two functions that are differentiable. Provided that u and v are two differentiable functions, that means that they can be differentiated. If you want to find the product, find the derivative of their product, you will simply be using this formula. It's u, the first function, multiplied by the derivative of the second function, plus the second function multiplied by the derivative of the first function. And like I said, since it is an addition, you can change the order, it doesn't matter. And it's easy to memorize, u into v prime plus v into u prime, or the other way around. Now, for these two differentiable functions, all you need to do is just memorize this formula. In this example, this is exactly what's happening. You have two functions. You can call them as u and v. They are both differentiable. You have to find the derivative of y with respect to x. Okay, so we'll just keep this formula in mind. dy by dx is u into v prime plus v into u prime. Okay, so if I follow this, u comes as it is. That's 3 plus 2 square root of x. Now I have to find the derivative of v. So multiplied by the derivative of v, over here you have the constant power rule, because you have a constant and you have a power over here. So when you differentiate this, what will you get?
Is it 15x squared?
Yes, 15x squared. And then minus,
okay.
This is a constant.
Minus that, you wouldn't put anything there, right?
Yeah, because we would get a 0, because the derivative of a constant is 0. So,
all right.
Yeah, I mean, you can, this is only because we're doing it step by step. Sometimes people confuse things, that's why it's better to write it down. But once you have a lot of practice, then you don't need to. Okay. So,
all right.
Minus 0, we can write it, we cannot write it, it doesn't matter. Now, that was only the first part, u into v prime. Now we have to write v into u prime. So that's 5x cubed minus 7. And u prime is going to be the derivative of this. Over here, again, we can see that we have a constant. So this constant, when it will be differentiated, will become 0. And we are left with 2 square root of x. Okay. So for me personally, sometimes whenever I have to differentiate square root functions, it gets confusing to do it in one go. That's why I write them down and differentiate them separately. So this is 2x to the power 1 over 2, right?
Yeah.
If I derivate this, this power is going to come on this side and multiply. So it'll be 2 times 1 over 2, which is just 1.
So that'd be 1.
Yeah. And then x to the power 1 over 2 minus 1. So that's x to the power negative 1 over 2, right? Which becomes equal to 1 over square root of x.
1 over square root of x.
Okay. So that's what this derivation will give me in the end. Okay.
Okay.
Now I will obviously have to expand this and simplify. So I'm going to multiply 15x squared 1 by 1 with both of these. So 15 times 3, that's 45x squared. Plus 15 times 2, that's 30. And this is x to the power 2. And 2 is being added to 1 over 2, because this is x to the power 1 over 2, right? So 2 plus 1 over 2 becomes 3 over 2.
3 over 2. Okay.
And then we are going to come here. Now, this is 5x to the power 3 divided by square root of x, right? X to the power 3 over square root of x minus 7 over square root of x. Okay?
Yeah.
So let's go ahead and simplify this as well. So 45x squared will stay as it is. 30x to the power 3 over 2 still stay as it is for the time being. And this is going to be 3 minus 1 over 2. Okay?
So that would be
3 minus 1 over 2
5 over 2?
is 5 over 2. Okay? This will be 6 minus 1 over 2. That's 5 over 2. So this will be 5x to the power 5 over 2, right? And then minus 7 x to the power negative 1 over 2. Okay? So we can take square root of x common if we want. That can give the function a slightly more, you can say, less complex look. Okay, so if I have seven over square root of x, I can multiply and divide this by square root of x so that the square root of x in the denominator is finished. I can rationalize it because we normally do not like to have square root signs in the denominator. So you have 7 square root of x over x. Okay, so this actually becomes 7 square root of x over x. Okay, if I were to take, say, square root of x common from all of these terms, I will be left with 45. This is 2 minus 1 over 2. So that's going to be 3 over 2, right? So it'll be 45 into x to the power 3 over 2 plus 30 x to the power 3 over 2 minus 1 over 2. So that's just going to be x, right? 3 over 2 minus 1 over 2.
Yeah.
That's 2 over 2. So you'll just have x over here. Then 5 over 2. I'm taking out 1 over 2. So that will be 4 over 2. That's 2.
So that's 2.
X squared. Right, and then square root of x when it goes from here, I'll just have 7 over x over here. Okay?
Yeah.
So this looks a little less complicated because I've taken the square root outside. Okay? So this will be the answer to dy by dx using the product rule. Okay?